Hello! Welcome to our website tutorial of Make. Make is an automated solution for building programs, but what exactly does that mean and why do programmers love it? If you already know the answer to this question, feel free to scroll down the page and dive right into this tutorial. However, if you don't know the answer to the question, this video will get you started off on the right foot. Let's start with a more abstract example before we dive in our C program. Let's say Donald wants to build a deck. Donald has never built a deck before and has no access to resources on the subject. So, he sits down and determines the deck consists of a foundation, supports, a floor with rails, and furniture. Donald also determines that he must build the deck in a certain order because certain parts of the deck can't be built until other parts are assembled. He writes down the proper order. First he must make the foundation, then he must make the pillars, then the floor with rails, and then finally the furniture. So Donald builds his deck. Finally, all Donald's work is paid off. The deck is finished. Later that day, though, Donald's wife gets home. She doesn't like the furniture and demands Donald goes and gets new furniture. He now replaces the furniture. No other part of the deck relied on the furniture, so the fix was as easy as that. However, even later in that day, Donald's friend Mickey comes over and notices there's a crack in the foundation. Yikes. Donald is forced to repair the foundation. However, since the pillars, deck, and furniture all rely on the foundation, Donald must start from scratch. Luckily, he wrote down all the steps of the process and what parts depended on what. Thus, Donald knows exactly what order he has to do it again to build a deck. In this example, the different parts of the deck represent the different files in a program, and the instructions that Donald wrote down represent the make file. In this tutorial, our sample program will be a triangle toolbox. It can perform 3 different functions: hypotenuse, area, and perimeter. Each of these functions are in a different .o file. Thus, the program triangle is dependent on area.o, hypotenuse.o, and perimeter.o. However, the existence of these .o files depend on the respective .c file and the triangle toolbox.h. This forms our dependency tree. It's an easy way to see what parts of the program depend on what parts. This program is similar to the deck example in that building the program requires a set of steps to be followed in a correct order. Also similar to the deck example, when one file changes, any steps that depend on this file must be rebuilt. For example, if we find out that we used the wrong equation in hypotenuse.c and we change it, now we have to rebuild hypotenuse.o and then triangle. Once you have written a makefile for your program, you'll never have to worry about dependency issues like that again. This is because Make keeps track of which files have changed and automatically rebuilds anything that depends on them, leaving you with an optimally efficient solution for rebuilding your program. Now that you understand how Make works, complete the example tutorial on the rest of this page to become a Make master. Thanks for watching.